Gears of War 3 was just a natural evolution. When we sat down and looked at Gears of War 1 and 2, I think that really the only conversation was, what aren't we satisfied with? Because there's 10,000 things that we are satisfied with. But when you look at a sequel, you're always saying, what are the things we did wrong? It doesn't really matter what you did right. You have to evolve, you have to push, you have to drive forward. We basically had the same team to make this game that we have in the past. But the scope is far larger. And so what that comes back to is efficiency. It comes back to tools, marrying the Autodesk suite of tools. And the Unreal Engine is, honestly, it's a no-brainer.
There's too many! Hostiles! Yeah, baby! Who's next?
My name is Chris Wells, and I'm a senior character artist at Epic Games. Working at Epic Games is really fantastic. I mean, the team is amazing. It's extremely rewarding to see the result of the teamwork and what we've made, especially with Gears of War 3. I think it's the most polished product we've ever created. I wanted to show you a little bit of how we use Max in our modeling pipeline as a hub for other applications, and as well as the use for hard surface modeling, as well as some marketing purposes, and some things that we've made the pipeline a little more efficient because of it. So one of the examples we'll start off with is just the process of modeling a character, and we're going to start off with a character sketch of Anya, as you can see right here, and pretty much standard form. You know, you take a look at what shapes you have, and nowadays the way you'd model, you'd probably want to work with the thought in mind that eventually it's going to go into a sculpting package. So one of the things that's helpful is to start very low, relatively speaking, geometry-wise, so that you can have some maneuverability in those sculpting packages. So we can take a look here, and for example's sake, we have all these elements here in a basic start to the high poly. And as you can see, it's not very dense, and the shapes are fairly simple. And you want to have them like that because if you're working in any package that you're sculpting with, the advantage to having such a low subdivision is that you can adjust the proportions very easily while maintaining the detail for the most part in the higher subdivisions without it losing any kind of fidelity or rigidness in appearance. One trick that is sort of useful that we'll show here in an example is what I've done is I've duplicated this shoulder pad element and I've moved it to this section here. And this will be what we actually use as the final version for, or start of our final high poly shoulder element. So we'll make a copy here. And going into edge mode, you can simply grab a row, as you would see here. Very simple. And using chamfer, we can chamfer these edges to the thickness we'd like. And one thing I like to do is to double chamfer. So the first chamfer, the initial one, sort of really defines the width of it, and the final one actually decides on how crisp the edge will be. So this double chamfer right here, we'll bring it to either 0 or roundabouts to get a nice crisp edge that we can see here. And so we can also refine the corners. And once again, what we're doing is we're trying to take the best of both worlds. We want to take a very basic form, basic defined form of a hard surface so that we can experiment with it in sculpting packages, because a lot of times, you know, as other artists may know, working in 3D, especially on very detailed models, there's a lot of back and forth between whether this feels right, whether the elements flow together. So you don't want to commit too early to something 100%. So we'll chamfer this edge right here, just for a little bit of fidelity. And we can also do here. So essentially we have this primitive object, or fairly simple object that we have that is high poly, but it's got a nice bevel to it. And what we would do with this original piece is we would both bring them into the sculpting package of your choice. And we would essentially project the detail from here onto this. As we subdivide each step for both of these models, we'll reproject once again and again as we go up. And once again, the reason we do that is twofold, because we want to capture that detail but be able to make those large global changes as we like with a relatively simple mesh, but you would still keep the corners. Also, you have an advantage using this lower polygon mesh as well, in that you have a more uniform geometry. So you're able to go higher in geometry count, and you won't run into a bottleneck where you'll have quite a deficit or quite a low amount of geometry on the top, but you'd have an extraordinary amount around the corners. And what you want to use this for is if you're going to use anything for stencils or for alphas. Say if you want to make an alpha where there are bolts or there are insets or anything else, it's very helpful to do this in this method, because you'll have sufficient resolution on this model after subdivision. So at this stage right now, we've essentially taken all of our projected models. We have our low subdivision models. We've worked on them in our sculpting package. We've added the dings and the dents and everything that we want to them. And so now we're just looking at an optimized version that is ready for processing or ready for rendering. So here we have the finished product. And as we can see here, we have plenty of resolution to add whatever insets we want in the sculpting package, and really not worry about topology at this point, because we're just placing them where we want. We don't have to worry about pinches so much, because we have pretty uniform resolution in terms of for geometry and pretty uniform topology. So now that we have that done, we can move over to the tracing. And tracing is tracing the high poly model with a new low poly mesh. And the easiest way to use this that I've found that's very useful is using graphite in 3ds Max. Using this as a start, let's isolate one part. And all I did is simply duplicate this or copy a polygon from the mesh, but you can obviously create that in any way you like. Let's just convert that to editable poly. Okay, so we have this here. We have our mesh that we are going to trace from. And let's open up graphite. And I normally choose surface and pick the surface. And normally something that's fairly close, say 0.2. And after that, we just simply drag and shift. And the thing I like about this technique, although others are faster, in some ways, you eventually wind up having to optimize later. So as you can see, we have so far the makings of a low poly model, but that's fairly efficient. It hugs the surface very well, so that means we'll get a higher quality projection as well. Because we've chosen an offset, the offset remains uniform, and we can be pretty confident that it'll get a good process out of it. Okay, with that we'll move on to the low poly. It will be considered the final product. One of the things we've learned about efficiency is using a universal head. So this is our universal head here, and we just basically agreed on had the animators look at it and the models look at it to make sure, one, it had sufficient geometry to model just about any head we needed, as well as the edge loops that were necessary around the mouth area or any of the facial area to properly emote and to convey the performance of the animators. To test this, what we did is create a female morph just as the proof of concept, and we also did a morph of Baird, an existing character. So this was pretty helpful. And in addition, you may see areas that are of different colors, and those are basically sort of guidelines just to let us know where of places that are already rigged facially. And so this would be about the limit of an area where you would move an eye, like this ring or these loops of geometry. Really define the limits of where the weighting is on the standard head. Not to say that it can't be adjusted, but just as a simple guideline. So essentially, as we create a new character, whether the high poly is derived from this universal head or not, what we simply do is to once again use the extend tool on the with the high poly head in the scene, and we simply tack on the verts to the head to correctly mimic the topology or the shape of the head that we want to extract detail from. And once again, this saves about a day, perhaps more, of time involved in creating corrective morphs, because all we have to do at this point is simply pass this head off as a morph target to the technical animator. And so far in our current tests, we haven't had any problems with it at all. It's been quite a success. So using FBX, we can import models that were rigged and animated in Maya and simply bring them over into Max without any trouble. One of the things I like in Max is that once I have a rough pose that I like, it's pretty simple to go in and make quick changes to relaxing geometry or to fix snags, and to make a final version, which can be used for marketing purposes, what have you. And this is an example of a mesh that we have rigged in Max, and this method so far has been pretty helpful. Just the ability to have a much quicker iteration, and to be able to not have to either learn a new program or re-rig existing work by having FBX file format. It's been quite a win for us. And with that, using that method, we've created several of these portraits, and this being the Lambert Berserker that you see. This was the final product of that, rendered in Unreal Engine 3 and obviously posed in Max and tweaked and polished in Max.
Look out! Here it comes!
Lambert Berserker! My name is Jeremy Ernst. I am a technical animator and character rigger here at Epic Games. I do everything from character deformations and skin weighting all the way to complex pipeline tools, writing lots of code in Python and Mel and things like that. I work very closely with the animators because really the rig is all about what their needs are. And if the rig could be the fanciest thing in the world, but if it doesn't meet what they need to do, then it's just not going to be very useful. So the first thing I wanted to show was the Auto Rigger tool set that we developed for Gears of War 3. One of the other things that I added in Maya was this nice little sidebar over here, which is kind of like basically a shelf, but very specific to our tool set. So we have Perforce integration and our editor integration, things like that. So the animator can just pull up the Auto Rig tool set, they can choose their project, and then in that project they can choose the character that they wish to work on. And so I'll choose Marcus, and I'll go ahead and hit build. The Auto Rigger is completely coded in Python using the Python integration in Maya. And it's a fairly standard rig, nothing super special. We have a couple of cool controls, but the big thing is that we have a nice character picker that is integrated into Maya's interface using the dock control command that was, I think, implemented in Maya 2011. And so with dock control, it actually allows us to kind of pin the UI into the interface, so no more floating windows, which is nice. And then in here we have things like selection highlighting. We can grab selection sets and shift select more selection sets, or grab everything and toggle selections on and off. We can also, blue is for FK, red is for IK handles. We also have kind of real-time switching and matching, so if I can pose the hand in IK and then I just go over to FK and click FK, not only am I now in FK mode, but I've already automatically matched my FK to the IK. And same when I switch right back. Now I'm back in IK, but I'm just in the right pose that I was in FK. One of the other things that we do a lot is kind of import in mocap from Motion Builder. We have a mocap studio here at Epic, and I can add mocap directly onto the rig by clicking the Add Mocap button. And so I'll import in one of our famous executions that our characters can do. So this is the face punch execution that you've seen probably in the beta. And the animation is going actually directly onto the rig controls itself. And so if I select any of these controls, you'll see the keys are all actually on the control, which allows the animator then to go ahead and add that control to a layer and make any modifications they need to. It also comes in on FK, and that's so that we get the exact orientations rather than estimated positions with IK. But if we wanted to put, say, the legs in IK, we could just go over to Tools and grab the Match Over Frame Range, change the enter in a start frame and an end frame, and then check which limbs we want to be in IK. So then I can hit Match IK to FK, and then this will actually match the IK legs controls over to the FK, and that way you can actually move the hips and the legs stay planted. So once it finishes up here, now the legs are in IK and they're all matched. So if I grab these keys real quick, now you can see that the legs are in IK, we're all matched up to what the FK was doing, and we have nice IK legs, so the legs stay firmly planted. One of the other cool things in the Auto Rig toolset is the ability to export out an FBX to be imported into our Unreal Engine. And there's a handy little export button here. If you click the export button, what you actually get is an FBX that gets saved out with your current timeline frame range and your current file name as the name. Or if you shift click it, you can specify a name. So we can do face punch execution, and then do a frame range. And then if I hit accept, it's just going to go ahead and actually give me a clean FBX skeleton exported out that I can just bring right into the editor. And what's nice about that too is with our old proprietary format, we used to have to basically degrade the scene. We used to have to bake down the rig and things like that. We'd ruin the scene, and if the animator were to hit save, they would now lose their control rig. And so this keeps the scene nice and clean, and all we get is a nice clean FBX exported out from this. We also can add a weapon as well, so I can just click on the Lancer and hit add weapon, and the weapon gets planted right where it needs to be. And all these things are very easy to set up. Setting up characters on the auto rig are very easy. Adding weapons to the project are very easy to do. So I'm going to build a new auto rig so I can show off some of the facial rig stuff. Over here I can click Add Face Rig, which gives me basically a face rig onto this character. And if I click the Face Rig UI button over here, it'll actually add a tab onto our existing UI. So I can go over here and I've got my upper face shapes, you know, that give me brows and lids and things like that. I've also got lower face shapes, which give me things like all the mouth controls, jaw drop, things like that. And then what you're actually seeing here on the screen, these little spheres, those are what we call our offset controls. So these attributes are driving a morph target. The mesh itself here actually doesn't have any morph targets on it. There's a cage driving those deformations. And as I animate one of these attributes, the offset controls are moving, but if I were to click on one of these, you notice that the channel box is actually all zeroed out. It's actually just going along with the ride with the underlying deformation cage, which means that any values I put on it are actually a true offset from that shape. So if I go back to jaw drop and I were to close the mouth, that offset stays there. So say your character always had a grimace on his face, you could kind of get that base pose, or if he had a cigar in his mouth or something like that, you could use these shapes and that character would maintain that offset throughout. You can also use these for kind of your fine detail pass or anything like that. We can take a look at what is actually going on in the face rig. I can open up the face rig container. I use containers for all the rigging stuff now ever since I think they were introduced in Maya 2009. They're a great way to kind of contain all of your parts. Like if I open up my actual rig container, every rig piece, head, hands, legs, shoulders, arms, they're all in their nice little containers, and that way I can publish the attributes up to those containers to kind of dummy proof the rig a little bit and things like that. So if I open up the face container, there's a cage here that you can see, and this is actually what's deforming with these attributes. These attributes are actually going to be driving this cage. Let's just hide everything else. So all these attributes here are actually driving this cage. This cage has locators pinned to the surface of it, and so as I animate an attribute, these locators are moving. Those locators have joints constrained to them, and that's where my offset controls come from. We have a low poly cage driving our deformations. The locators fall along with that cage, and then the joints are the ones that are actually constrained to those locators, and that's what the mesh is actually bound to. So that gives us our final face rig. And what's nice about that is we can transfer that to any other character by just making a new cage that fits that character's shape. And that's how we're able to get a face rig made for our characters in an incredibly fast manner. So that actually kind of, I want to show the universal head topology, because that's another part of this facial rigging process that we use. What we tend to do with this head is the modelers use this head to kind of shrink wrap it to a high poly sculpt that they do for another character, and that allows us to add that sculpt as a morph target. So we can turn this head into Baird just by adding that morph target. And what's great about that is if we go into the Paint Weights tool, you can see that the weights all transfer over, but now they're in a new position relative to that new shape of the head. So from here, all we have to do is export these weights out to a file. So I can just say, and then all I have to do is reposition the bones to where the new mesh needs them and re-import the weights, and I'm done. So within 5 minutes, I can have a newly weighted head just by using this universal topology. And it can do some pretty interesting things, like I can bring in another head. So I have a woman that has a very different head shape. And all I have to do is add that in as a morph target. If if I go ahead and hide this and then go over here and apply that morph target, now I can go back and look at those weights, and everything is exactly as it should be, but in the new position. So then I can just re-export those out, move around the bones, re-import the weights back in, and I'm complete with my head weights. So that's a very useful kind of pipeline that we developed for Gears of War 3 that has saved us a ton of time for rigging our faces and for our cinematics. And then I know Chris Wells showed the Lambert Berserker model, and so I wanted to kind of tie that in with the rig. We spent a lot of time trying to come up with a good tentacle rig. This guy has 6 tentacles or something on him, so there's quite a few. And one of the best things I found, I think we talked about this earlier too, was that, you know, sometimes the simplest tools are the best ones. And so using a combination of simple tool sets that are already existing in Maya, I think came out with the best tentacle rig. And so what we have here, these yellow rings represent FK controls. So we have 3 easy to pose FK controls. And then we can use these little circles in here as our spline IK to kind of get the curve that we want. But we can still use our FK control to drive that overall shape. And so we're basically posing with our 3 FK in broad strokes and then kind of setting our definitive shape with these spline IK offset controls here. And that just allows for very quick posing of these tentacles. And then obviously we have a little character picker over here. We can add mocap on this rig as well. One of the other things that I thought would be kind of cool to do at some point was kind of be able to actually view the mocap you'd be importing with a play blast. So you could actually, just from inside Maya with that little UI, you could actually launch a play blast of what that mocap is and see what you're going to be importing before you actually import it. So that was kind of useful. And then one of the other things I always like to do with rigs is kind of have visibility, especially with a rig like these creatures where they're very complicated and there's lots of things going on. It's nice to be able to kind of hide things you don't want to see, so the animator can just focus on, say, the core motion of the body and the legs and get that down, and then go ahead and add in the arms, and then eventually start adding in tentacles one at a time. It just makes it easy for them to animate, and that's all about really making it easy for them to see what they need to see and animate what they need to animate. So that's pretty much the Lambert Berserker.
My name is Maury Mountain, and I'm a senior artist at Epic Games. I focus on mostly 2D art. I do textures for models, like creatures and characters and weapons, and some environment textures. And I also do interface design and 2D art. We wanted to improve on everything that we had done in Gears 2 and make the interface within Gears 3 to be the most robust interface that we have ever made. We were able to make the UI fully functional by using Scaleform for the integration into our engine. The first thing I wanted to show, one of the new features we added in Gears 3, we updated Horde, which is our game type, which is you and a couple friends versus hordes of enemies. One of the features that we added to Horde this time around, instead of just a straight up just kill everybody that comes your way and hold up in a base, we added fortifications. So we added fences, we added decoys and turrets and sentries and all these complex things that were new to the franchise that we wanted to have, and we wanted a way for you to level them up. And in the old version of Horde, we didn't have any sort of thing that we had to communicate to the player of, we need to let them know that, oh, this wall is now level 2, you leveled up, or this thing is level 3, this completely new concepts to Gears of War. So we were presented with a big challenge of how do we do this. With our old system, we had a series of pop-outs that would slide out from the side of the screen and say, have a little icon and say, this is your progress. This is, you're now 500 of 1,000. Congratulations. And that ended up, we tried that, and it was a little cumbersome just because every time you move through the map, you'd have like 6 things popping out, and we were really frustrated. So we wanted to come up with a solution to make that more clear to the player. And we decided to use Scaleform to communicate that on the HUD, on the heads-up display in the game. And we went through a couple iterations. This first concept shows just a simple array of buttons at the top. They're not really buttons, they were just indications of like this. These are the things that you have available to you. This is the level they are. This is what they are, and you can or can't build them. And we tried this method. It didn't really work. It wasn't balanced. Tried it on the left-hand side of the screen. It was a little bit better, but we wanted to show our objectives in the game as well, because we started having, like, if you're playing in wave 4 and it says headshot all the enemies and we give you bonus points, it's like a little mini quest within the round. And now putting it on the left, we ran out of room, or just run out of room on the screen, so we shifted stuff around, put it on the right, and it worked out. This is the final design, and this is the Photoshop mock-up that I had made just so that we had a layout. It got approved. Design loved it. We all loved it. Thought it worked great. So then we went to building. Since we were using Flash as a tool to build the UIs in the game, I decided to mock it up first too, to see kind of how it would work. And in using Scaleform, this was helpful to me because I could take this mock-ups and these animations and sketches that I had made and turn them into actual game assets really quickly. My first thing that I built was kind of a test of of it sliding in and how the kind of buttons would look, what the states of the buttons would do, like how progress would happen, and or how we could communicate progress, showing progress bars. And this early sketch was just an early sketch, and I scrapped it. It was a bad idea, and so I switched to another process using Flash, where I captured a video of the game, brought it in, made some quick animations within Flash, and I can show you what that looked like finally. So this is the animation that I created that was just a simple mock-up of this is what we wanted to look like in game. And I built this in a couple hours, wanted to show it to design, show it to people, saying, like, this is what I'm thinking of, let's try to get this going and get it working. Also for a working prototype that I could show the engineers for that when I gave them all the parts and pieces, like, this is the proven concept, this is what we want, fire off these frames at this time, and I could just pass this off. And also it was a good source for communication to upper level designers and producers, saying, hey, look, this is what we're going to have, this is going to be cool and we're going to like it, and we do. So from taking this, I built all these assets just using straight up Flash components and art, and I was able to convert it into a file that we could import straight into the Unreal Engine. I started with a base level, let me go to the normal frame. I just built the same mock-up that I had in Photoshop in Flash using bitmaps and some Scaleform click components, labels and loaders, and just assembled it and made some animations to turn it on so that whenever it first comes on in gameplay, it's noticeable, it's fast and flashy. Initially, we didn't have this flash we added it because players weren't recognizing the fact that it's turned on. Your eye wasn't being pulled over there, so we decided to add a little bit more. And that kind of just the flexibility and power of Scaleform allowed us to do that really quickly, where we had a test and people were, oh, what something came on the screen, I didn't even know it was there. And so we're like, all right, we're going to make this painfully obvious. And building out animations. And the great thing with Scaleform as well is that we were able to build one individual chunk for all of the icons and modularly shift it around and instance it in the file so that it could be reused. So we only were building one piece of content that had multiple functions. So this little icon has an on state where it turns on. There's a state when you build. There's a state where it changes color if it's too expensive, and unlocking. When there's nothing there at all, we blank it out. When you upgrade, when you get within proximity of it, we made states to glow and fade. And so all this stuff was built, all this functionality was built for this little widget that we then used on all of the chunks. And we made the blank one because we only have 5 fortifications. So instead of having a sixth one here that looked like something, and people were like, what, is something there? It's like, there's nothing there, it's blank, and it's blank for a reason, just modularity with just keeping things even. One of the great things that we've used a lot on Gears of War 3 were the click assets provided in Scaleform, and click are pre-made components and objects that do things that are useful in games, such as drawing text, having a way to load external images, making lists, making lists driven by data. And for this, the icons were made using click widgets. The click widget for the loader is just a simple Flash clip with a shape inside of it that we reference in code, saying whenever you are object 1, you will be using this icon, so then the player can relate that this is that part. So I'm going to load up a Horde game here to see the HUD on the right in action. We have the timer ticking down, which indicates how long you have to build your fortifications, and the icon will glow green as I approach it, just to let me know, hey, you can build. We want to just communicate in every way possible. And I build, and it flashes, and now it's too expensive. So I have $0. But the progress bar underneath the fence, the caltrop, indicates how far along I was, and right there the timer's out, so we fade it out, get it out of the way for gameplay, so we can be able to kill all locusts and keep the screen clear. One of the things we really wanted to make sure we had in the multiplayer and just in the game in general was to keep the screen as clear of clutter as possible. Compared to Gears 2 and Gears 1, building the HUDs, and for those games, this was it was amazing to use Scaleform, so that I could make it in Photoshop, I could import my PSD and straight up just see it right there positioned, and then everything was perfect, and I pass off my Swift file to the engineers, and they draw it, and it all works, and there's no giving screen coordinates. This isn't a percentage of the screen from the left-hand side, but now it's a percentage of the screen at the right, and all the crazy convoluted steps that were involved in building UIs in the past, it feels like that's just out the window. Like, the second thing I wanted to show was a portion of the in-game UI to show player stats. This is an early concept of one of the ideas that we had, that when we were looking at it, design was saying this wasn't showing as many stats as we would like, so we iterated on it and came back to a design that was a bit more modular. This is a design that is similar to the one that's in the final game. We made some tweaks and changes after the fact, due to some technical reasons and just visual feedback that we got, or feedback we got from the developers and people. We just wanted to change some things. So the goal with this screen was to show as much data as possible and to not have it be a big burden to build and to maintain. So in building it, we broke it up into parts where modular parts, where the top left would be a player summary section, where this section could toggle out based on what game type. If you were in versus mode, we can show your kill to death ratio. If you're in beast mode, your kill to death ratio isn't that important, so we change it up and show different stats. Your online persona and your XP is kind of just your gamer tag, your title, your medal, which this is a static, constant part of the UI. The bulk of the data and meat of this section of the UI is this section here, which is all modular, where we have a predefined size where we could build new chunks, and we wanted to just be able to slice whatever we wanted in there. Like, we wanted to put a pie graph. We could build a thing with a pie graph and show it in there. We wanted just to be really flexible. And the footer for that section, we broke this up so that we could see everything as a whole and be able to put stuff in and intelligently build it in Flash. And leading into that, going straight into Flash, so this chunk here represents the data portion of the stats page. This section up here represents the player's persona, where we were able to build multiple sections or multiple states, so that if you come in, you have never played the game before, you'll just see your gamer tag. You don't have a medal assigned, you don't have anything, so right now it's just your name. And when you assign a medal, we change the state up. So using Scaleform and Flash like this, it just made my life and engineers' lives so much easier, because we could come in and make this, and we realized later, well, wait, we can assign medals. We want people to be able to see the medals on their name. So I came in, added some frames, added a label, passed it off saying, hey guys, I just added a thing. I added a new frame label called medal. Just call it whenever someone has a medal. And they were like, sweet, yeah, that's easy. The engineers worked their magic, and whenever you have a medal, we change the layout. Near the end of the project cycle, we were coming up with some polish time. We're like, okay, we want one more cool way to show the weapon stats, and we were kind of near the end, like crunching, just trying to figure out like how we're going to get everything done. And we're like, well, we can't add anything new, but we decided to add something that would parse the stats a little bit differently to give you a comparison of all your weapons. And and again, in a short amount of time, like it was maybe half of a day, I was able to build a new list item renderer that allowed us to have a progress bar to show kind of you spend 50% of your time killing with, or getting kills with this gun, or 20% of your kills are with this gun, 10% here. And we wanted to have a cool bar graph to show that. And in a short amount of time, I was able to come in, build a progress bar, and have a number attached to it and animate it, and hand this off so that the engineers could say, all right, well, they'll do the math, they'll figure out what the percentage of that is, they'll pipe it into that bar, and we'll display it. And it was almost miraculous how easy it was to just, I could do that quickly, say, hey guys, I made a progress bar, it's going to be cool, just give it a number 1 to 100 and whatever, it'll work. And just thinking that, I was kind of like crossing my fingers, hoping it would, not sure of the outcome. And when it worked, it just blew me away. And I just knew it was like, this is amazing. This tool is awesome. I can do whatever I want and just make cool stuff. This is the versus stat screen of the version, or the in-game version of this that we were looking in Flash earlier. This is all the parts and pieces put together. The upper left with being the player specifics, your player persona with just my gamer tag, my debug gamer tag, and the big stat chunk here in the middle, or on the right. And it can just cycle through and show all of the pages that we had built in Flash, the individual list of, just the generic list of stats to show as much data as possible without it being a giant scrolling list or something that was just really cumbersome to find what you were looking for. It just was awesome, and it really made me feel great to have these cool stats in here.
There's no reason for us to reinvent the wheel. Autodesk has created a massively powerful suite of tools, and all we need to do is make it shine in games like Gears of War 3. I mean, it's the biggest Gears of War game we've ever made by a huge margin. The multiplayer is robust to a degree that players have never seen. We have dedicated servers. We have Horde mode. We have a new Beast mode where you get to play as the Locust. We've got a campaign that's bigger than any campaign we've ever done. Higher quality cinematics, higher quality graphical fidelity. I mean, at every turn, this is a bigger and better and more impressive and more striking game than we've made.